Welcome to Astronomy Daily. I'm Anna, and you're in for quite a fascinating show today. We've got a great lineup of stories that showcase just how rapidly our understanding of the cosmos continues to evolve. From NASA's ambitious new SphereX mission beginning its journey to map hundreds of millions of galaxies, to some dramatic developments in lunar exploration and a mind-bending discovery from the James Webb Space Telescope that suggests our entire universe might be inside a black hole. Yes, you heard that right. We'll also look at a groundbreaking new map of our galaxy that's helping astronomers see through the cosmic dust that surrounds us. It's an exciting time in space exploration, and we've got all the latest developments coming right up. NASA has just confirmed a major milestone in space exploration with their SphereX mission successfully establishing contact and beginning its groundbreaking science operations. This extraordinary observatory is now preparing for what promises to be a revolutionary 2-year survey of our cosmic neighborhood. SphereX, which stands for Spectrophotometer for the History of the Universe, Epoch of Reionization, and ICE's Explorer, will undertake the ambitious task of mapping more than 450 million galaxies and over 100 million stars in our own Milky Way. But this isn't just about counting celestial objects. The mission aims to answer some of the most fundamental questions about our universe. In the coming weeks, mission controllers will be fine-tuning the observatory, conducting crucial calibrations, and cooling the telescope to its optimal operating temperature. Once everything is properly aligned and configured, SphereX will begin creating what will become the most comprehensive 3D map of the entire sky ever attempted. One of the mission's primary objectives is to investigate a phenomenon called cosmic inflation, that brief moment just after the Big Bang when the universe expanded faster than the speed of light. The telescope will also measure the collective glow from galaxies, including those that are too faint or distant to be observed individually. Perhaps most intriguingly, SphereX will search our galaxy for hidden reservoirs of water, carbon dioxide, and other ingredients essential for life. This could provide valuable insights into how common these life-supporting materials are throughout the cosmos. What makes SphereX particularly special is its ability to complement the work of other space telescopes, like Hubble and James Webb. While those observatories focus on specific targets in great detail, SphereX will scan vast sections of the sky quickly, creating an unprecedented cosmic census. Better yet, all of this data will be freely available to scientists worldwide, essentially providing a new encyclopedia of hundreds of millions of cosmic objects. The past few weeks have brought us a mixed bag of lunar landing updates, with some remarkable achievements alongside sobering challenges. Let's start with the exciting news from Firefly Aerospace's Blue Ghost mission, which touched down successfully in the Moon's Mare Crisium region on March 2nd. This landing gave us something we've never seen before. Unprecedented footage of a lunar touchdown captured by special cameras designed to study how spacecraft interact with the Moon's surface. The Scalpus-S camera system aboard Blue Ghost recorded the entire descent sequence, starting from about 91 feet above the surface. These images showed us exactly what happens when a spacecraft's engine plumes first interact with lunar soil at around 49 feet up, creating a fascinating dance of dust and regolith that will help engineers design safer future landings. If you'd like to see some of the video footage and check out more details, take a look at our latest blog post on our website at astronomydaily.io. However, not all recent lunar missions have enjoyed such success. Intuitive Machines' Athena lander faced significant challenges during its landing attempt last week. While the spacecraft performed flawlessly during its journey to the Moon, a critical altimeter failure meant it couldn't determine its exact height above the surface during the final descent phase. This led to a dramatic landing where Athena struck a plateau, toppled over, and actually skidded across the lunar surface, rotating several times before coming to rest in a small, shadowed crater. While the spacecraft managed to survive this rough landing, the impact kicked up regolith that covered its solar panels, severely limiting its power generation capabilities. In even more challenging news, NASA's Lunar Trailblazer mission has been struggling since shortly after its launch on February 26th. Mission controllers lost contact with the small satellite just one day after launch, and despite continued efforts to reestablish communications through NASA's Deep Space Network and other ground stations, the situation remains uncertain. These contrasting outcomes highlight the inherent challenges of lunar exploration, even as we develop increasingly sophisticated technology. Each mission, whether successful or not, provides valuable lessons that will help improve future attempts at exploring our celestial neighbor. All right, this next story just might blow your mind, so to speak. The James Webb Space Telescope continues to reshape our understanding of the cosmos, and its latest discovery might be its most mind-bending yet. Recent observations have revealed something extraordinary about the rotation of galaxies in the early universe, a pattern that could suggest our entire universe exists within a black hole. And yes, you heard that right. During the James Webb Space Telescope Advanced Deep Extragalactic Survey, scientists observed 263 distant galaxies and found a striking pattern. Rather than seeing random rotation directions as expected, approximately two-thirds of these galaxies are spinning clockwise, while the remaining third rotates counterclockwise. In a universe governed by random chance, we'd expect to see an even split between rotation directions. This coordinated cosmic dance raises profound questions about the nature of our universe. According to Dr. Lior Shamir, who led the research team, there are two possible explanations for this phenomenon. The first and most intriguing suggestion is that our universe was born rotating, an idea that aligns with theories of black hole cosmology. This theory proposes that what we observe as our universe might actually be the interior of a black hole within a larger parent universe. Even more fascinating is the possibility that every black hole in our universe could be a gateway to another universe, though we could never observe these other realms directly due to the nature of black holes' event horizons. Polish physicist Nikodem Poplawski suggests that when black holes form from collapsing stars, the extreme conditions prevent matter from compressing indefinitely into a singularity. Instead, the matter reaches a state of incredible density before bouncing back like a compressed spring, potentially creating a new expanding universe, much like what we observe as our Big Bang. If our universe did indeed form inside a rotating black hole, it would inherit that rotation, which could explain the preferred direction of galaxy rotation we're now observing. This axis of rotation would be passed down from the parent universe's black hole, influencing the formation and movement of galaxies throughout our cosmic neighborhood. However, scientists are also considering a more mundane explanation, that our own galaxy's rotation might be affecting these observations, though previously this was thought to be too slight to matter. If this turns out to be the case, it could require a significant recalibration of how we measure distances in the deep universe, potentially resolving several other cosmological puzzles in the process. In other astronomy news today, in a remarkable breakthrough for astronomical research, scientists at the Max Planck Institute for Astronomy have created the most detailed three-dimensional map ever made of cosmic dust in our Milky Way galaxy. This groundbreaking achievement utilized data from an astounding 130 million stellar spectra, combining information from both the European Space Agency's Gaia mission and the LAMOS spectral survey. Think of cosmic dust as nature's cosmic filter. It affects how we see everything in space, making distant objects appear both redder and dimmer than they actually are. It's like trying to look through a slightly dirty window into the vast expanse of space. Until now, astronomers have had to make do with relatively limited information about how this dust is distributed throughout our galaxy. The new map was created using innovative machine learning techniques to analyze the way starlight interacts with dust particles. By studying how dust affects light at different wavelengths, researchers can determine not just where the dust is, but also its composition and properties. This level of detail far surpasses previous efforts, which only included about 1 million measurements. But the study revealed something unexpected. Conventional wisdom suggested that in regions with higher dust density, the dust's effects on light should become more uniform across different wavelengths. Instead, the team found that in areas of medium density, shorter wavelengths of light are actually absorbed much more effectively than longer ones, a finding that challenges our current understanding of how cosmic dust behaves. This discovery has led researchers to propose an intriguing possibility. The unusual absorption patterns might be caused by complex molecules called polycyclic aromatic hydrocarbons, or PAHs. These molecules are the most common type of hydrocarbon in interstellar space and may have played a crucial role in the development of life itself. This new dust map isn't just an academic achievement, It's a practical tool that will help astronomers make more accurate observations of distant objects. By knowing exactly how much dust lies between us and our astronomical targets, we can better understand what we're actually seeing when we look out into the cosmos. It's like finally having a clear understanding of how dirty that window really is, allowing us to see the universe more clearly than ever before. That's a wrap for today's episode of Astronomy Daily. I want to thank you for joining me on this cosmic journey through some of the most fascinating developments in space science and exploration. From breakthrough discoveries about our universe's possible connection to black holes, to new missions exploring the moon, and groundbreaking maps of our galaxy's cosmic dust, it's been an exciting lineup of stories. If you're hungry for more space news and want to stay up to date with the latest developments, I've got you covered. Head over to astronomydaily.io, where you'll find our latest blog posts and a constantly updating newsfeed of space and astronomy news. It's your one-stop destination for everything happening in the cosmos. And don't forget to join our growing community on social media. You can find us as Astro Daily Pod across all major platforms. That's Facebook, X, YouTube Music, TikTok, and our newly launched Instagram account. Follow us to get your daily dose of space news and join the conversation about our fascinating universe. This is Anna, signing off until our next cosmic adventure. Keep looking up, and remember, the universe is full of wonders just waiting to be discovered. See you next time on Astronomy Daily.